Tiffany and myself. Table of contents, project introduction, system description with diagrams, technical description, operation and electrical characteristics, summary and references. This is the complete circuit, working circuit. The fire alarm project consists of 4 circuits. The temperature monitor circuit, which displays current room temperature to each fire alarm circuit, which is designed to send an audible alarm when a certain temperature is reached. The amplified circuit, which amplifies the signal from the fire alarm circuit. Power indicator circuit lights up 2 LEDs indicating power to the circuit. That's the monitor. The LED screen, capable of displaying 80 characters, 4 rows with 20 characters on each. ATMAEGA 168 IC chip. High performance, low power design, 8-bit microcontroller. 131 instructions, most of which are executed in a single clock cycle. Up to 20 MIPS input at 20 megahertz. Memory includes 60 kilobytes, a programmable flash, and 512 bytes of EEPROM. The monitor circuit LM34 transistor are precision integrated circuit temperature sensors whose output voltage is linear proportional to the Fahrenheit temperature. 7805 5 volts regulator. Employee built-in circuit limited thermal shutdown, safe operating area protection, which makes the virtual immune to damage for output overloads. It's a 3-terminal positive voltage regulator. Schematic. The LCD monitor.
Okay. I'm gonna discuss the LCD, the monitor a little bit. Here's the chip, the main chip right here that we had to program. We had to program it with using the C program with the computer to program it to display the temperature of the room or whatever situation you have it in. With every computer, you have to have a clock. We insert this little crystal here that is clocked at 14.7456 megahertz to give the computer's timing. Here is the LM34, which is the sensor cell that sends the temperature by resistance, and then the computer calculate the resistance and turn that into the temperature, whether it's Fahrenheit or Celsius. In this case, we have it programmed for Celsius. On our circuits, that's a USB card that we have to hook up to our computer to program the chip. We don't have it installed on our board for, simplicity purposes, but we had to install it, for loading the chip. And there's the regulator that you saw not too long ago that provide the whole circuit with the 5 volts that it needs to operate. And here is a switch that when we in program mode, you have to close the circuit so that you can program the chip. And then after you finish programming, you will just open back up the circuit so that the program can run.
That's the actual fire alarm circuit. And the NE55 timer IC chip. That's 3 operating modes. Monostable mode is the mode the 555 functions as a one-shot. Applications include timers, missing post detection, bounce-free switches, touch switches, frequency driver, capacitance measurements, pulse width modulation, So a stable free running mode uses include LED, lamp flashes, pulse generation, logic clock, tone generation, security, alarms, pulse positions, and modulation, etc. In the bistable mode, the Smith trigger. If the DIS pin is not connected and no capacitor is used, usually include bounce-free latch switches. 10K thermos that we had trouble finding.
Yes.
It's a temperature sensing element composed of centric semiconductor material which exhibits a large change in resistance proportional to a small change in temperature. Usually have negative temperature coefficients, which means the resistance of the thermistor decreases as the temperature increases. BC548, BC558, SL100B transistors. Semiconductor device used to amplify the switch, electronic signals, and electrical power. It is composed.
Sorry.
Go.
I don't know if I can go back.
Well, stay with this.
Okay.
Other components: capacitors, resistors, diodes, red LEDs. Schematic for the.
Okay. This is a schematic for the fire alarm that we just did an overview of. Right here is the 555 chip, IC chip. This part of the circuit, we deleted this part of the circuit so that we can add the amplifier to the, so we can amplify it a lot louder than what this circuit will provide. So we actually have four different circuits that we put together to form this project. Yeah. Those are
Transistors.
the transistors, two transistors right here, and here's that thermistor that sends the temperature and change its resistance, and when the resistance goes up, the temperature will go up, and vice versa. Going down, temperature will go down. Right here is a variable resistor.
We thought you were done.
Yeah, well, actually, there is, you can't go back, and this is our enterprise circuit.
I can go back on the computer. Back there, look
There it is.
Yeah, variable resistor, and other components, capacitor. But your two main components is your thermostat and your 555 timer IC.
I don't have that one
You
here.
don't have
Here's
this?
what the amplifier circuit looks like on the proto board. As you can see, here's the 555 timer with the variable resistor. Next. The amplifier circuit consists of a 386 IC chip with a 5K ohm potentiometer, 100 microfarad capacitor, a 220 microfarad capacitor, a 0.1 microfarad capacitor, and a 0.47 microfarad capacitor. Also have a 100 ohm potentiometer, 10 ohm resistors, and an 8-watt speaker. We actually added another 8-watt speaker onto that as well. Here's the power indicator circuit. This lets us know that power is reaching the circuit, and when the alarm is activated, the lights actually blink a little faster when the alarm sounds. This is what the power indicator circuit is made of. It is made of 2 LEDs, green and white, 2 N3409 transistor. We have 2 of those, a 100 ohm resistor and a 470 ohm resistor. 2 of those also, each. Here's us in the developmental phase. That's me on the left, if you don't know me. Now we're doing some research on the microcontroller. We had a little bit of trouble doing the C++ program to get the microcontroller to boot up, to display the temperature. We finally figured it out though, and here we are with the circuit. It is. I don't think it's all the way complete there. We only have 1 speaker. I think that's before we added the 2nd speaker.
Just getting it together.
Yeah, that's where we're just getting it together. Here's Joseph on the left explaining the 555 timer to Andre. And on the right, I believe we're looking up some schematic diagrams.
And eating lunch.
And eating lunch. Yes. Our references, of course we went to Google. We got our data sheets from alldatasheet.com. Got our schematics from wiringschematics.net. I'm not sure what did you get from there, Joseph?
I think on the data sheets was from that last one.
Okay. We're going to give a shout out to Matt, our teacher, and Patrick. He helped us out. And that's it.
Demonstration?
We're going to do a demonstration.